Hi everyone. In this video clip, I'm going to show you how to solve this vector question whereby we need to apply the concept of similarity. Now let's understand the requirement of the question first. Now, first of all, okay, the diagram 9 shows a parallelogram OABC. So OABC. APD, so we have to look at where are these points while we are reading. DCB, okay, and what else? OPC, APD, they are all straight lines, okay? Given that a parallelogram, we have to mark this down to show that they are parallel. So mark down the opposite pairs because they are parallel. And then the other important information is OA equals to 6A. Okay, let's put down in the in the diagram. OA is 6A. So if this is 6A, the CB is also 6A. Okay, CB is also 6A. You've got to write down. Who knows? Later we may need to use this. And then OC is 12C. So OC is here, is 12C. And if this is 12C, the other side, AB is also 12C. AB is also 12C. And then we have the ratio of OP to PC equals to 3 to 1. Okay, normally I write up, one down so that I can compare. See, OP take up 3 units, yeah? So let's write 3 units from O to P. And then P to C is 1 unit. So let's write the number and circle it to show that this is not the actual value. This is just the ratio. And then since we have OC, so I can just add another column to show the relationship of OC to OP and PC. You see, OC, if OP is 3 parts, PC is 1 part, OC is everything, it will be 4 parts. Not only we can compare the magnitude, we can also compare in terms of vector. So from O to C, we know that it's 12C. So like we can also find based on the ratio and proportion, this is 3C and this is 9C because 4 times what give us 12 times 3. So everything must times 3. Okay, so we got a lot of additional information. So now we can solve AP. Let's see, the vector that they give us represent the existing path that we have. So we have this as our existing path. The rest we don't have. So how do I move from point A to point P? So you follow the path. That is A move to O, and then from O, move to P. So what is AO? We have OA 6A. So AO will be the opposite. So we put negative 6A. And OP we just found here by using the ratio and proportion. So it's 9C. So we found the answer for AP. Now next, we have the area of PDC. So area of PDC is here. Okay, the area of PDC is given as 4 units squared. So area of small triangle, yeah, just put small, equals to 4 units squared. And we also given the perpendicular distance from A to BD. So let's mark it down, 90 degrees here. It is 5 units. Okay, now if they give us the perpendicular distance, so we relate it to the area of triangle, isn't it? But the area of the triangle for this 5 unit must be the big triangle. But this is a small triangle that we want, the small triangle that we are given. And we also know that one of the sides of the triangle, they're actually parallel. So when they are parallel, even though it's not the same size, since they are parallel, we say that they are in proportion. So when the sides are in proportion and they share the same angle at D, so we have the similar triangle. So you must understand the concept of similar triangle. Okay, this side parallel and they share one of the angle. All right. So because when they are parallel, this angle will be corresponding to this, and this angle will be corresponding to that. So when all three angles, they are corresponded to each other, and therefore we say that the triangle are in similarity. So with that, we can use the concept of similarity to find. So given the perpendicular height of big triangle, we can find the perpendicular height of small triangle. Let's label it as PM. Okay. So we know that PM, the perpendicular height for small triangle, over the perpendicular height for big triangle, which is 5 units. Then we take the corresponding parallel side, which is the PC. Yeah? The PC, we know that the vector is 3C. So take the sides of small triangle compared to the side of the big triangle. Okay, can you see that? Small over big. So the other side must be small over big for the corresponding sides. Yeah? So we will have PM equals to, this one simplified 1 over 4 times 5. So we found that PM to be 5 over 4. Or we can just write 1.25. Okay, so we found PM. And next, we can put this one in our calculation in area of the small triangle, which is 4 units. We can take half by the base. The base is DC, okay, times with the height, which is PM. And we found PM to be 5 over 4 or 1.25, up to you. So 5 over 4 easier. Therefore, DC equals to 2 times 4 is 8. Bring up times 4, 32 over 5. And this one we can get 6.4. So we got DC to be 6.4. Now, how do we find 6A? So over here, we can, same thing, we can use the similarity. So the small triangle, yeah, okay. We take the DC, all right, the DC compared to the corresponding sides of the big triangle. Okay, and DC, you straight away put the value in 6.4 over for the big triangle, corresponding side is 6.4 plus 6A. Yeah? Don't just take 6A because 6A is only the green one. It's not even the full triangle yet. So we don't take the green one. We should include the DC. So they will be in proportion as the other side. So this is the small one, this is the big one. So we take the small sides over the big sides, which is the 3C, the same side that we take, 3C over 12C. And we got 4 here. So we have 6.4 equals to 1 over 4 times 6.4 plus 6A. Okay, this one bring up. So we will have, okay, 6.4 times 3 equals to 6.4 plus 6 modulus A. And this one bring over. So 6 times of the modulus A, we got 3 times 6.4. Is it 3? Oh, sorry, it's 4 here. Okay. So 4 times of 6.4 minus 1 times of 6.4, yeah? So we will have 3 times of 6.4. Factorize. I'm using factorize. Or else you straight away use calculator. You should get the answer here. Okay, you divide by 6. So it will be 6.4 over. This one divide by 6, you got half. Therefore, 6.4, you half it. You got 3.2 as our answer. Okay, so that's it for this part. So the most important thing is you know how to apply the similarity. Okay, that's it. Thank you very much. Should you have any question, please leave your question in the comment area. I'll come back to you as soon as possible. Hey, thank you.